All right, so I'm presuming everyone who's going to be here is here to see this. So a few weeks ago, I went to the States to present at Gradle Summit, which is a conference devoted exclusively to Gradle, which is like just to a build tool, which is, I've never seen that before, but I suppose it goes to talking about how big Gradle is. So this is going to be the shortened version. The talk I gave was 90 minutes, and I never thought I could actually do a 90-minute talk, but believe it or not, you do lots of examples and you can stretch it out. So if you find yourself in the same position, that's a good tip. So I'm going to talk about a single-page web app that we built, and that single-page web app, we chose to use Gradle. We initially didn't choose to use Gradle, but we ended up using Gradle for a reason I'll go into. I'll talk about the support for building JavaScript and CSS assets. I'll talk about how we organised our Gradle build, and I will talk about taking advantage of other plugins in the Gradle space to use more of the JVM features. So back in September last year, we had Luke Daly from Gradleware come and tell us about Gradle, and I think that picture by Tom sums it up perfectly. Why Gradle? So planting seeds, it's like, okay, we'll start using this Gradle thing at work. We had a few Java projects using Gradle, and that was all very well and good. And we basically said, okay, well, we're going to build a single-page JavaScript web app. Of course, we won't use Gradle, we'll use Grunt, or use something else that's more popular instead. Fast forward a few weeks ago, that's the Gradle Summit. That's the keynote breakfast thing. That's Luke Daly again. Oh, by the way, when you become a conference presenter, you get a laser pointer. So now I've got a clicker on professional. So this was basically, who's been to Yao in Melbourne? You've got the 3 streams of talks. You've got roughly around the same number of people. So I think it did pretty well for just a build tool. Yeah, I found myself going around full circle and coming back to Gradle again. So I'll tell you about the app and how we got there. It's as I said, it's a single-page app. It's basically for our client. They run reports. It's got some filters on it. It shows them some graphs. I did a talk a few months ago now here talking about Google BigQuery, so it was talking to Google BigQuery in the back end using its JavaScript APIs and using Google Charts for the back end. Initially, there was no, it was all just JavaScript, so reporting front end, single page JS web app. It's got the Google APIs inside it, just uses that JS API to talk to BigQuery, and then charts come back to the users. And then later on, we added in Tomcat. We added some security and some other stuff that the Java container gave us. That's a picture of our app there. It's got charts and it looks very businessy. So it's all good. Oh yeah, I've got animations. Fantastic. All right. The libraries that we use, it was pretty simple. So most people go, oh yeah, to be a single page web app, you need something like Knockout or Angular or what else? Backbone, something like that. We just kept it massively simple because our app was quite simple as well. It was jQuery, Bootstrap, a whole bunch of JS libraries, and that was enough to get us going. But we still had some challenges in doing that. But we got our proof of concept together, and with that, we basically had a static HTML page with a bit of JS includes at the top, CSS at the top, and JS includes in the bottom. Pretty standard. We were doing things pretty hacky, so it was just literally importing all of them. We weren't using require or anything at this stage. And so we decided we got to get hit and start picking up some new tooling. So this project I found while researching for my talk. This is actually there's a project called JHipster, and what JHipster does is it takes Yemen, Angular on the JavaScript side, and it's got on the basically Spring MVC and what else? Sorry. Oh, thank you. Yeah, I picked the shirt. I just need the bow tie. So it basically wraps it up in a Maven or a Gradle build. It was just interesting. So it's like a one-stop shop here. You build all your assets, and I'll put them all together for you, and use the Java backend side, use bits that you need for the Angular side. But this only got Gradle support a few weeks ago, so I didn't know about this at the time, but the picture kind of says it all, where a lot of us have probably been with, oh yeah, now you've got to build a single page JavaScript app. Go Java developer who's done Java all their life. So this is where we were as well. So the first step is you get this thing called npm, and that's fine. We had to set our client's proxy details, and you go npm install and whatever packages you want, and it looks good, it starts going, I'm going to get all these things for you, and then it fails. And the failure reason is something low level within the OpenSSL library that it depends on for HTTPS communication. And it turns out that a lot of these tools, like everything, uses OpenSSL libraries, and they all have this problem. So you go into Stack Overflow, and they basically find wget and git and all that have this special workaround that basically says if you've got one of these ugly proxies that gives you this error, tell your tool or proxy to not verify SSL. There's a flag. Just say don't worry about it. And yeah, okay, that wouldn't really fly with our corporate IT client. So we had a bit of a think. Well, first we had a bit of a cry. After the cry, we had a bit of think, and this quote came up at Java 1 last year. JavaScript's basically reinventing the world. They're climbing the tree of software development awesomeness, and then falling down, taking every branch on the way down with it. And so, to a whole bunch of Java fans in one room, that's a great thing to say. But it probably encapsulates, they're reinventing the wheel, rightly in some cases, but wrongly in others, where there's a lot of maturity in the Java build tool space. So for us, Gradle, we had already done projects with it. We already got it working past the proxy. We didn't have any silliness to deal with. And at the same time that we were looking at this, we were validated by a few blogs that came out. And so, this basically, whilst had we gone down the Grunt path, we would have learnt that at the start of the year, Grunt and Require.js were now not cool anymore, and it was supposed to use Gulp and Browserify, both of which are still built on NPM, which still would have dealt with our issues. And then further validation on Twitter, where Grunt's not hitting hotness anymore, and considering how bloody awful it was to configure, I was expecting a replacement sooner. So that kind of validated that I didn't need to worry about the JavaScript hype, and I could continue being a Java developer and use Groovy and Gradle. So this guy here, so Gradle doesn't have any official JavaScript support or CSS support, but this guy, Eric Wendelin, he's a champion. He now works for Twitter, doesn't do anything specific to these plugins, but still maintains them. So he's built the Gradle.js plugin and the CSS plugin. There's a few other ones for Gradle, but they're the newest and they're still kept up to date. And behind the scenes, if you've done anything, like if you used Row4j, the project, if you've done using any Maven plugins, the pattern is the same. Basically, there's some jar that wraps up Rhino JavaScript engine, which calls the JavaScript tool that does the minification and this, whatever else in the JavaScript land. And that's the same pattern that's been applied here. It's a Gradle wrapper for those tools to do those minifications. But the neat thing is that because Gradle's got this awareness of task outputs and knows what assets, what's incoming, what's outgoing, if you change any of the incoming things, it goes, right, I know you're not up to date, I need to do something and run the task action. And this is where the Gradle awesomeness starts coming into play. So it builds an awareness of what's built and what's not. So if you go to America, buy this guy beer, because he's pretty awesome for doing this off the bat. And he last updated that he's keeping that plugin up to date. You just need to do apply plugin JS and apply plugin CSS. It's not quite the whole story, because then you need to tell, because those plugins don't come with Gradle, you need to tell Gradle how to get them. Bernie mentioned Gradle 2 came out, and one of the other announcements at the Gradle Summit is that there's a new plugin portal, so plugins.gradle.org, so I can type in here JS, and it tells me, oh yeah, there's the plugin by Eric, and I go in, and then it tells me all about it, what the new features are, and then it tells me if I want to use it in Gradle 2.1, I can just define this. Is quite straightforward. I just need this plugin version and apply it, and Gradle knows about it. Compared to the older version of Gradle, so if you've used any other third-party things, this is what you've got to do. So Bernie's example previously had his 10 Queen Street GitHub project in to reference.
We were actually using the Gradle wrapper.
Oh, okay, yeah, fair enough. And you had it all fixed in there, yeah. So yeah, you have to define the repository your plugin comes from and the class path and the dependency separately. So it's a bit longer-winded. You don't actually have to do this with Gradle 2, but we were still having to do it. But it's not a big deal. And I'll show you later how to split this stuff out so it's not all a big monolithic Gradle build file. But this was kind of like, Eric's great and he keeps the plugin maintained, but what we came to find is there's also times when he's got a personal life that takes over, and so there was versions when we upgraded from Gradle 1.0 to 1.11 and 1.12, and just it didn't work anymore, and that was because it was using some internal Gradle API which you weren't supposed to use, and therefore, ta-da, didn't work. But the cool thing is that because it's open source, and a win for open source, as Bernie said before, there's people who are contributing to the GitHub project, they're submitting patches. Eric may not have gotten around to applying those patches yet, but you can see the discussions on the issues page, and it was pretty easy to then go and find one of these patched versions and compile it and go and start using it. The other thing about this was that actually learning about any undocumented features, you could go into the source code. You had the source code to actually look in and understand the plugin a little bit better and how to use the features as well. So that kind of helped. Basically, if you are using third-party plugins or third-party anything, but it's open source, go to the GitHub project because you'll find solutions to your problems. And there's even, like Eric's in there, there's got even features that aren't actually supported. He's got workarounds. He's got issues open where he's gone, oh, well, this is how you implement it, even though it's not on my roadmap. This is how you would do X. So it's just worth keeping an eye out. Gradle tasks. So once you apply the plugins, you get all these things over here. So combination, gzipping, less CSS, minifying, require, and a whole bunch of stuff keeps getting added all the time. I'm going to talk about these things just to get you started. So I'm going to use Bootstrap's got a dashboard. So I'm just going to keep our app simple and build it on the way up. When you get the Bootstrap dashboard, these are the minimum files that you need. A dashboard CSS, a dashboard JS, we've got our build.gradle and our index, and it's pretty much how we started as well as developers. So we didn't have any kind of Maven source main web app or anything like that. We just started as it was like that. And then you go, okay, well, there's this libs directory and I need to get all its libs. So then actually, when I expand that all out, there's a whole bunch of CSS files over here and JS files down here, and then the jQuery libraries also have their files as well. So we've got to think about now changing our HTML to include all those things. It's a bit of a pain. I'll talk about that in a sec, but it's old-fashioned. So you just, shock horror. We've got to get them off the internet and copy them in. But I've been doing that long enough to kind of go, okay, that's okay enough.
There is a new alternative called WebJars.
WebJars.
You can do it new way.
All right.
And I'm doing this new way.
All right. I will we'll talk more.
There's also Bower.
Yeah, well that needs NPM.
Yeah, Bower.
Dying.
WebJavaScript is Java based.
Yeah, cool. So yeah, everything kind of stemmed from firewall, NPM, and then yeah, ecosystem dead. But we've got a solution for that as well. So we'll get to that when it's time. All right. So combination and minification. In your Gradle build script, you declare a source set. So here's our dev source set. We're just saying this folder, please give me all the CSS files and exclude all the already minified ones. And then we can give that source set to a combined CSS task and tell, say, where to put it. And this builder just is a property that's defined in the Gradle build stuff. There's minification. With the minification, you can specify the cool thing about Gradle is that it understands. I can just specify combined CSS, and that means it knows I'm referring to the destination of the previous combined CSS task. So I think that's quite low level. I can see at a very easy, high level, this is how these things are chained together. I don't have to have a property, like if I was doing this in Ant, I'd have to create the directory, have bits to create the directory, I'd have a property to represent that directory, make sure it's created, do all this kind of stuff. Gradle takes care of it for me. And then the next time I go to run minify CSS, it'll go, oh, hey, did this thing run over here? Do I have this destination file? Has it been changed? Has its dependencies changed? Oh, no, I need to go and run new as well. So it's just a little bit of syntax sugar. Gzipping is the next step. So at this stage, we're just saying we've got an all.min.css.gz. A Safari browser, all our browsers will get it, and I could have also just clobbered the previous file, but then I'd lose the build sequence. But it's much of a muchness. So just to show that it actually does stuff, combine CSS, build successful, we get our all CSS, then I run minify, and minify, I've already run the combined CSS before, so it's up to date, then it goes to run the minify. Then we've got our minified version, and then I want to do the, what am I doing? I'm just showing you that this is the minified version that fits in only 10 lines of code, which is Java developers you'd be very happy about. And then gzipping, so we go from a 1539 byte file to a 438 version gzipped. A 917 minified to 438 is gzipped. And then to prove it's gzipped, there you go, I just covered it out.
So where were you deploying this?
So initially, we were deploying to just a local Apache server, but there's support for Jetty and Tomcat in here, which I'll talk about later as well. So we actually wrote tasks in Gradle to copy that source set and all those files into the local, like the var ww, the directory for our local Apache. But then Gradle would figure out, oh, hey, I need, this has changed, I need to copy stuff across. However, we move on to Jetty and stuff later on, so I'll talk about that. So I talked about CSS. With JavaScript, it's much the same. But the thing is that we were kind of lucky with our CSS in that we didn't really have any ordering dependencies. All the files were nicely namespaced and didn't really matter. But with our JavaScript, you probably know that ordering is important. So we had a set of core JavaScript files and application files, and then we had some development mode stuff, and BigQuery and so on and so forth. So you start, ordering is important. You've got to have all your constants loaded, for example, before you start doing anything serious. Here's a thing just that with Gradle, we had to learn how to use its logging, and you can log properties of stuff, so you can log anything just for any debugging sake, and destination files. So we're saying, yeah, just put together this all.js, and this is all our libraries. So that's all those guys here are all these source sets. So it's just these are just Ruby arrays. So just list arrays with some interpolation of some Gradle properties in there. But yeah, basically it'll pull that all together and bring it one big minified. First it'll combine, then minify. We've got some source map support, so that just means that if I'm debugging in Google Chrome or Firefox, that even though I'm using the minified file, I can see the source from the normal version. This thing over here is really cool. So because it's using the Google Closure JavaScript Compiler, you get all these extra features. One of those is these compiler options is define replacements. So it's basically anywhere I can set variables in my JavaScript code, and the Google Closure Compiler will be smart enough to put them in. So I've got a debug flag, and I guess the Google Closure Compiler is like it's like a compiler. It removes dead JavaScript code branches and does some other smart refactorings. There's a simple mode and an advanced mode and all this funky stuff. But we just found where we wanted to have, say, for example, just a bit of code to say, hey, you're in development mode. We wanted to have a bit of jQuery just popping up saying, in the corner, add this to some particular div to say dev mode. We could use this debug flag to switch that feature on and off. So when we're in debug mode, on the next page, I'm talking through this all. So normally by default we'd say the debug flag is true, but because the Google Closure Compiler is smart enough to recognize these documentation annotations, and that's all you get in JavaScript. It's not like Java. You're just like literally looking at the doc and figuring out, oh, this is a constant, it's type boolean. I know that I'm allowed with this define directive that I can throw this away and change this at compile time. So what we've done here is I've said, hey, I want this to actually be false. So even though in my JavaScript code I've set this variable to true, when the Google Closure Compiler gets to it, it's going to set it to false. And then I can do something like an if statement, just saying, here's some dev info that you wouldn't normally want to see. Right, so basically just a way of hiding at compile, like injecting in, having some sort of constants, which you don't really, I don't know what you do otherwise in JavaScript other than have inject a different file of different constants for prod and different for dev, and then still have that code there. But the thing being too, Google Closure Compiler, if this is set to false, this whole block doesn't end up in the final code that goes out to the client. So that way you're not, the client won't ever see, in the production version, won't ever see the if statement that you're trying to do some stuff, and then that could be like a security risk. Someone, like they could expose a potential security hole. So the fact that it's never even going to make it into the production code at all is probably a nice little thing. And like your opinion might vary on that. But,
Can you explain Closure Compiler?
So that's just a Google. I'll bring up the web page towards the end, but basically it's a JavaScript compiler, and it does, or maybe it's a transpiler is a better word. I'm not sure what the term is, but it's basically does a whole bunch of enhancements and looking at your code. So it does the minification for you and does any kind of changes to the JavaScript file necessary as part of that.
It has nothing to do with the language closure?
Oh no, yeah, so CLOSURE, not COLCOJ. Yeah, so yeah, I know it's a Java meetup, sorry. There's potential closure developers in here.
And were you able to make working both those Google Closure thing with source maps? Because like I'm using similar tool, and it's not possible to have them both, because like for source maps you need to switch to Uglify. It's not working with Closure.
It's a good question. I
wasn't able to make it working.
My development environment for this, we used IntelliJ with some web, I think it's WebStorm is their IDE, and WebStorm's got this live edit plugin. So we kind of didn't even touch on this we didn't develop out of the minified version anyway. So it was only, so I don't know, maybe I'll go tomorrow and I'll go and see, oh damn, it doesn't work. But, yeah. You might have a thing there. So yeah, again, gzipping. One thing, like, so I went and explained to you that how awesome it is that Gradle can see that another, can see the, the destination of a previous project, and I can just say, use the source as the previous projects, so previous tasks. So just I'll show you here. So I can say combines like this minified uses the combine JS, but it doesn't implicitly, like if I run minify.js and this hasn't run, it doesn't go automatically to run minify.js. So that to me was a bit unintuitive, because I would have expected, hey Gradle, you're so smart at understanding that you need to, recompile something. Why didn't you just go ahead and do it? But if I don't specify at the command line minify, then also combine, then minify, it wouldn't run it unless I did. There we go. Oops. Okay. Unless I did this. So specifying the task dependencies. So if you've done Gradle before, then this is where you can just specify your task chain. You can also do it when you declare the task as well. But basically, once I do this, then it goes, okay, well, let me just check, has combine done its thing first before I do minify? Has gzip, has the minify task run before gzip? I'm probably going to submit that as an issue and see what they say. Just didn't get around to it, but it's just obvious to me that probably should happen. And most of the Gradle plugins, in some way, shape or form, do this in the background anyway. So, for example, if you have the Java plugin, I believe if you run the jar task that the Java plugin brings in, it goes and will run the Java compiler and stuff anyway. So it just seems like that's a bit of an oversight as to why it's not done the Gradle way. But I've only got 3 minutes, so yeah, we found that once we started adding all this awesomeness, our Gradle file was from here to the roof. And so what you can do is you can actually then start. So this is build.gradle and our properties, and then we can bring in we can basically split out the concerns of the build into separate build.gradle files, just to make our heads a bit more clearer. And then what we do in the normal build file is we can just reference them. So this was at the top of the main build.gradle, referencing all the other ones. So I've got Tomcat. So we started off with Jetty, and that was all fine. So basically, a developer can check out the code, and they've got a container, they've got a server ready that's already pointing at the thing. So they don't have to set up, they don't have to download anything. They're just there, ready to go. If you use Grunt, that's the equivalent of Grunt server, I believe. So Gradle Tomcat run for us. There's Jetty run as well. The Tomcat's a third-party jar. We got it even set up to do SSL, and it was awesome. It was good. But basically, you've got the live edit features. You can change your JavaScript and CSS directly in your IDE, and it updates on the next refresh. And if you've got the live edit plugin that I was talking about before for IntelliJ, or you use the equivalent NetBeans one, same thing. You can actually just change the code in the IDE, and your browser will update without needing to refresh. So now you've got a way of starting up your code, seeing what it's actually doing. You've got a way of minifying it, and you can basically specify dependencies to say, when I do the previous version, I want to, once I've run the minify, I want to run Tomcat run and point it to this directory where I put the minified version in. Let's see, here's some examples here. So I'm specifying just a stop port. That's our context path. We want to tell it it's SSL. One thing that it didn't come out of the box was that it didn't tell me that Tomcat had started. It would be like starting Tomcat, but it's got this default message saying go to localhost 8080. So we just had to put use Gradle's do first to say for these Tomcat tasks, just have a message to tell developers it's actually port 8443. And then here, down here we're saying, Tomcat run depends on a dev boot libs. So we had some tasks to swap out the development and the production libraries around. Just back in a sec. Right now, actually. So, as I was mentioning, normally you've got this, you put all your libs and your CSS at the top, and then this does scroll down. I'll skip to the time, but at the bottom you've got all your JS. What we used was this thing called head.js, which basically, because we hadn't, there's require.js, which basically says you've got to define everything's got to be a module, and there's a certain format to it. But because we started off as a proof of concept, what head.js lets us do is specify actual JavaScript files as modules themselves. So in the back of our minds, we had this concept of that this would have to be a modular JavaScript file, and we separated our concerns of our app into different JavaScript files. Head.js just basically gave us a way of saying, of defining the chain of the order of those files. I don't have an example. If you're interested, I'll show you that later. But basically, it's just a whole set of after I've loaded, the core dependencies, go and load the next library, and so on and so forth, and I can define the whole chain in there. But this is what we did. We had some, so to solve the problem of the source, like basically once you've got one minified version, you just want to refer to all .min and .css and all .min.js. You don't want to have to refer to a whole list, a tree of libraries. So we wrote this task in Gradle, which basically we're telling it to do some cool stuff. Gradle, we're creating a task called Webapp bootlib task, and then what we're doing is we're defining that we're taking in a HTML file, which is just our index HTML. We're saying what mode we're in, and we're specifying an output HTML, which itself is just the index file again. And what we're doing is here's our reference to head for our dev mode, where we want to use head.js to pull everything in together. In our production, we want to refer to the all.min and the JS version as well. So what we did is we just wrote some Groovy code to do a string replace on our HTML. It's softening it out. But what I think is a nice example is just simply looking at how Gradle manages its inputs and outputs, so that it's only going to run this one. It's not going to run this string replace as part of my build every single time. It's going to be smart enough to know, hey, I last touched the file here. I don't need to run this bit of code again. And so I just thought this was neat in that I'm using stuff in the JDK here to change my HTML file. So it might be something dinky or what, but I found it useful to be able to swap those out. And then the cool thing was that by default, when the developer checks out, it just tells them, please run this task to get the right dev or mode into play. So Java, I talked about bringing Tomcat and or Jetty in. The other thing you can do is when we needed to do our security for our app, we basically putting it into a container so we get all the servlet security for free. So what that means is this is a web.xml file that defines what are the pages that users can see, the ones that are secured, and the roles, and how to log in and form stuff. So we got all that stuff for free, so we didn't have to worry about any kind of weird or learn any JavaScript authentication stuff. We just had a Tomcat container with its normal Tomcat JDBC, went to this table and away you go. It was quite simple. So that was kind of nice that we could build this single page web app and just now getting Java features that you'd normally get out of a Java container for free in our single page JavaScript app. And then Grunt, so I've covered there's the serve task. There's basically tasks for running. So there's basically an equivalent usually for what you could do in Grunt, you can do in Gradle through all these plugins and stuff. But some of the time, if you're using Angular, for example, Angular has directives which are basically doing minification and stuff anyway. And so what you can actually do in Gradle is Grunt plugins for Gradle. So you can basically say, go and do this Grunt task, and then that's add some of that knowledge back into the Gradle build, so it's not rerunning things when it doesn't have to. So a lot of my colleagues on other projects who are using Gradle, they're using the Grunt plugin to basically call off and run the Grunt tasks where necessary. But it's not always, it's basically for that Angular stuff. And if you've thought about it a different way, you might not need to even call the directives, just use Angular directly in your code without it still providing the minification and stuff from Gradle. So, just some points to take away. So you can use Gradle to build single page JavaScript web apps. You get everything from checkout, so the developer is ready to go straight away. The other neat thing is that you've got everything's in one build file, so you can see your CSS, and you can see your JS, and you can see your Java, and I think that makes, you don't just have this invisible barrier of projects where the Java developers only know about what the Java project's doing, and if they really have to, they have to check out the JS side. It's all in one spot. So I think that's important for refactoring and stuff. Just the fact that I'm changing something, and my Control-Shift-F is going to point out some JS files that I need to update as well. The last thing, of course, proxies. So that's just to say about the maturity of the Java space and the build tools. So it's just, I found it reliable. It wasn't perfect, but I found it, it easy to get support through the Gradle community. I found it also that where I didn't know how to do something in JavaScript, I could actually fall back to Java and fill in the gaps as well, because I had that platform maturity there. And with that, thank you. I've got a blog, so I talk more in the blog about what we did in specifics, and there are all the photo credits there as well. But, thank you. I got to about 37 minutes, so at least it wasn't 90. Yeah, cool. Andrew?
When you were running Gradle before, say in the screenshots, were you invoking Gradle from scratch or hooking into the Gradle daemon?
Okay, so the question was, was I running Gradle from scratch each time, or was I running the daemon? So the daemon was running, because the daemon will run by default unless you can specify. So some people don't like the daemon and they'll switch it off in Gradle W or wherever else you switch it off in. But yeah, I've been using the daemon. I had some issues if I was using IntelliJ and then I was using the command line. Sometimes they would conflict, and probably the most time I noticed the conflict was with shutting down the Tomcat or Jetty plugins. That even if I just shut down the servers, the daemon would still hold onto them and still hold onto the open 8080 or 8443 port. And so I'd actually have to shut down the daemon just so Gradle -- stop, just to shut down Gradle, so let go of everything so that I could start the next instance again. So it was that part was a little bit strange.
Well, I only ask because when I'm using Android Studio for Android app development, I think that's actually starting Gradle from scratch each time, and it seems to add a bit of overhead.
Yeah, you could just see from if you ran, say, JPS or use JConsole or something to see what flags were running. So the JInfo, those flags will tell you. And also I think there's some type of command for actually seeing what daemon tasks are running. The other thing though I found was if you have multiple versions of Gradle installed, which is perfectly plausible if you're got GVM or whatever, got just a whole bunch hanging around, you've got to use the same version. The Gradle daemon will restart if say your command line is pointing to 110, but your IDE is pointing to 111, and your wrapper is pointing to something else. It'll invoke all different versions and start different daemons for each one.
Do you consider alternatives for those JavaScript and CSS assets management? Like, for example, we used WRO4J, so it's doing almost the same thing with those JS Gradle and CSS Gradle plugin.
Yeah, so I think Row4J, I only know it from working with you guys, and it was a Maven plugin.
Yes.
So Maven. That's Maven. That's uncool. I'm gonna be a hipster.
But they're supporting Gradle as well, but they're agnostic of the platform.
Have they changed? Yeah. So when that was one of the first ones that we looked at, but I didn't see any Gradle support at the time. I don't know if it's changed now. Yeah. Maybe yes, definitely. Yeah. And that's actually quite good. It's got SAS support and it's got a whole variety.
Everything that you mentioned, yeah.
Yeah.
It's all possible over there as well.
Yeah. Yep.
Given you've got authentication and assets and all that sort of stuff, if you knew where the project was going now, would Grails be a better fit?
Yeah, so again, for the recording, the question is, would Grails be a better fit knowing that it supports all these things out of the box, and being a JVM developer, would it be good? So, look, that was plan C for Grails. So Grails recently with 2.4 introduced an asset pipeline and made that the default for any new Grails project, so just to be like Rails. So it crossed my mind, but I wasn't the only developer in the team, so I had a bit of Grails experience, but the rest of my teammates didn't, so then it would be just another thing to learn on top of that. And I suppose if you try to go, hey, this is best practices and where everyone else is going, then then that's probably just going to lose out a little bit to that. So yeah, it's just a thing about your teammates and getting something that looks like you're going forward as well. So that's how it